Hello, this is Martin from the Math Center. I'm going to go over a basic mathematical induction problem. So starting off this problem, we have 2 plus 4 plus 6 plus dot 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 plus 2n is equal to n times n plus 1, and we're going to prove this by induction. So for the base case is n is equal to 1, and we have dot 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 plus 2 times 1 is equal to 1 times 1 plus 1. And so you can see we have this base case is true. We have 2 is equal to 2. So the base case is true. Now we can move on to the induction hypothesis. And we're going to set n equal to k for the induction hypothesis. So n is equal to k. And we have dot 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 plus 2 times k is equal to k times k plus 1. And we assume that this case, the hypothesis case, is true. So we assume the kth case is true. So now we move on to the induction step. We have we set n equal to k plus 1, and we substitute that into our problem. We have okay, so we have dot 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 plus 2k plus, sorry, that's a 2k plus 2k 2 times k plus 1 is equal to k plus 1 multiplied by k plus 2, well, k plus 1 plus 1. So we have, simplifying that, we have dot 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 plus 2k plus 2k plus 1 is equal to k plus 1 multiplied by k plus 2. So we know, we substitute this in from the induction hypothesis, this 2k part, and that's equal to k times k plus 1. So k multiplied by k plus 1 plus a 2 times k plus 1 is equal to k plus 1 times k plus 2. So we could factor out this k plus 1, and then we have a k plus 1 times a k plus 2, which is equal to the right hand side, k plus 1 multiplied by k plus 2. So we prove this by induction. So here's a mathematical induction with factorials problem. We have 2 times the factorial of 1 plus 5 times the factorial of 2 plus 10 times the factorial of 3 plus dot dot dot. We have n squared plus 1 times n factorial is equal to n times n plus 1 factorial. And we have to prove this by mathematical induction. So for the base case, we set n is equal to 1. We have dot 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 plus n squared plus 1 times n factorial is equal to n times n plus 1 factorial. And substituting n is equal to 1 in this case, we have 1 squared plus 1 times 1 factorial is equal to 1 times 1 plus 1 factorial. And we can see that we have 2 times 1 factorial is equal to 1 times 2 factorial, which is just 2 is equal to 2. So we proved that the base case, n is equal to 1, is true. And so we could go on to the induction hypothesis. and we set n equal to k. So n's equal to k. Now we just substitute k for every n. We have k squared plus 1 times k factorial plus, or is equal to, k times k plus 1 factorial. And we had just assumed that this case is true. So moving on to the induction step, we set 8n equal to induction step. We set n equal to k plus 1. So we have dot 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 plus k squared plus 1 multiplied by k factorial plus a k plus 1 squared plus 1 multiplied by k plus 1 factorial. And we say that this is equal to k plus 1 multiplied by k plus 1 plus 1. I guess just rewrite that as k plus 2 factorial. Alright, so now we just simplify this by plugging in our induction hypothesis. We know that this term here is equal to k times k plus 1 factorial. So we have k times k plus 1 factorial plus, now we have to expand this. So we have it's k squared plus 2k plus 1, well, 1 plus 1, so it's k squared plus 2k plus 2 multiplied by k plus 1 factorial. That's equal to k plus 1 times k plus 2 factorial. So now we could factor out this k plus 1, these k plus 1 factorials out of the, just factoring these out, we have k plus 1 factorial multiplied by k plus k squared plus 2k plus 2 is equal to k plus 1 times k plus 2 factorial. Simplifying this further, we get k plus 1 factorial times k squared plus 3k plus 2 times, in the previous step I accidentally dropped, no I didn't, forget that. I didn't drop anything. I forgot that I factored out this k plus 1 factorial here. So it's still there. Continuing, we set this equal to k plus 1 times k plus 2 factorial. And this is a factor. So factoring this out, we have we get k plus 1 and k plus 2 times k plus 1 factorial, and that's equal to k plus 1 times k plus 2 factorial. So now we can see that this k plus 2 times k plus 1 is actually equal to this k plus 2, and this k plus 1 factorial is equal to k plus 2 factorial. So we have, in the end, we have k plus 1 times a k plus 2 factorial, which is equal to the right-hand side, k plus 1 times k plus 2 factorial. And we just proved that this by induction.